Hello, my name is Christina Graham. We're going to be talking about Spring and the many benefits that it offers and how it can help you build a better enterprise. I would like to start by giving you a high-level overview of what this presentation is about. The use of the Spring framework is advantageous to enterprise development and aims to facilitate Java enterprise development while also improving programming best practices. Spring addresses complexity of enterprise application development by providing a range of services and complementing existing technologies rather than reinventing the wheel. An enterprise application is software that meets the needs of an organization rather than an individual user. It aims to improve the productivity and efficiency of the business as a whole by providing business logic support functionality. It also has isolated functional tiers, client, middle, and data, and utilizes service architecture so that bundles can share common services and resources among the applications. It also has one common data storage where all data for the whole entire organization is persistent. The Java Enterprise environment made it easier to develop and run enterprise applications. However, it has many disadvantages as well, including lots of plumbing code. It was overly complex. There was a lot of effort needed to develop, and it had poor performance. In efforts to alleviate some of the pain realized in Java Enterprise Edition development, the Enterprise Java Beans were created. The goal of the EJB specifications was to standardize back-end business logic. Sometime after EJB specifications became widely accepted, developers realized the overhead and performance drawbacks of it. EJB was far from lightweight. Each component required 2 interfaces and an implementation class. Not only was the component unnecessarily complex, but it also was not portable, as it would only run on the EJB containers. Lastly, it needs the Java Naming and Directory Interface, or JNDI, to look up references to the Java beans, which adds even more overhead. In 2003, Dry Johnson released Spring, which is essentially an open-source application framework and a version of control containers. It focuses on creating a solution for the areas that other frameworks cannot address. While Java Enterprise Edition laid the groundwork for a portable enterprise application, Spring worked on improving the many downfalls it had and facilitates developing with it. Spring addresses the complexity of enterprise applications by providing a range of services and complementing existing technologies. Spring framework modules provide the following services. Inversion of control, aspect-oriented programming, data access, transaction management, model view controller, MVC, remote access framework, convention over configuration, authentication and authorization, remote management, messaging and testing. Inversion of control. Spring is most widely known for its inversion of control standard and use of dependency injection, of which there are several benefits. First of all, it minimizes the amount of code in your application since you do not have to worry about how the services are created and how references to these are acquired. You can also add additional services by simply adding a new constructor or setter method with no extra configuration. Testing your application is also very easy to do since you can switch implementations by simply injecting different objects into the code under test. Using dependency injection creates a departure from the factory design pattern and produces loosely coupled code as the dependency is injected into the requesting piece of code rather than the code explicitly requesting components or services. Spring will provide the greatest return in an application with many components that can be combined in different ways, since it makes it easy to swap out one for another and make wiring these components simple and centralized. In addition to allowing easy configuration of our application components, Spring also manages the life cycle of these beans. Unless otherwise specified, all beans will be instantiated as a singleton, meaning only one instance of the bean will be managed, thus reducing the number of resources required to run the application. In the same token, Spring handles destroying the singleton along with managing the rest of the resources in the application, as they all belong to the IOC container. This allows the developer to focus on their business logic rather than managing the life cycle of their objects. Aspect-oriented programming. AOP is another fundamental component of Spring. It differs from object-oriented programming in that it is concerned with aspects rather than objects. An aspect is basically any functionality that cuts across multiple parts of an application. Spring allows you to add interceptors to methods so that you can perform other logic before or after the methods execute, thus creating custom aspects in your application and providing an easy way to implement security and authentication to the application. It facilitates this by allowing you to intercept a client and the service method is trying to call and implement your authentication or your security there and decide if the client has permission to access the controller that they're trying to access. OSGI, Open Services Gateway Initiative. Earlier, we mentioned that Spring aims to facilitate development with J2EE. In the same respect, it also makes other existing technologies easier to use and allows integration of new frameworks and technologies seamless. The adoption of the Open Service Gateway Initiative furthered the efforts to increase separation of concerns into modules and increase the reusability of code. Since an OSGI application allows you to have deploy bundles without bringing down the application first, this also means that you can change the implementation of your Spring beans at runtime as well as modify the existing configuration of your beans. Transaction management. This can be a consuming task to accomplish in an application. Spring offers comprehensive transaction management support, making data persistence easy to implement and maintain. It offers support for JPA, JDBC, Hibernate, JPA, and JDO. This means that the programming model will be consistent regardless of which API you choose to use for data persistence. Hibernate is one of the most commonly used persistent frameworks, and in conjunction with Spring allows the developer great flexibility. Hibernate is a pure Java object relational mapping, or ORM, and allows you to map plain old Java objects, POJOs, to relational database tables via XML configurations. The use of ORM relieves the developer of persistent-related programming and shields them from messy database queries, resulting in improved productivity and maintainability of code. Using Hibernate also makes the code more portable since it is agnostic of the underlying database. Database-specific queries are generated at runtime. Spring provides a portable platform to run applications on the Java virtual machine. It is a lightweight solution for enterprise applications that reduces development complexity. It promotes reusability of modules, produces clean, testable code, and makes existing technology easier to use.